Okay, welcome back to my programming in ARM assembly video series that I'm putting together. Let's go ahead and jump right back into our code. Alright, so when we left off in the last part, I was working on this print.s function so that we could just have all of our messages that are printing out to the screen, have them handled here, and the characters would be automatically counted rather than the way we were doing it originally, which was counting everything by hand. There's a little bit of a bug here in the code that we have to figure out, so let's get going on that. But before I do that, I just want to say I changed up how I'm saving these files, because I was originally just making a copy of the main.s, but it occurred to me, now that we were having multiple files, it would make more sense to have subdirectories. So my vid5 subdirectory has all the files that we were working on, and then they're preserved as they were there at the end of that last video. Okay, so yeah, let's look at this. Let's look at print.s first and just see if there's any obvious problem here. So let me just check these registers. We're preserving R0, R2, R3, R7, and that's fine because that's all we're using. And then we're popping those. And so that should be fine. So is there an issue with our count? There could be an issue with the count. So let's go into the debugger and start looking at this. So let me see. We expect our prompt to have a count of 15. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah. So that means when we get to by the time we get here, R2 should contain the value 15. So let's gdb main, and let's find a good place to stop. Let's actually, I wonder, I'm just gonna set a breakpoint there, like immediately, and just hopefully it'll stop at a good point. Let's run it. Okay, good. It stopped before we ever got in there. So I want to step into the print function rather than step over it, because I want to see everything that's happening. So rather than using in to go to the next, well, in works like step over, and s is like step into. So I want to go s and then s again, and that should step into the print. Yeah. All right, so step. So that's going to preserve all of our registers, which are probably, at that point, they're probably empty. But again, we want this to be general purpose, so it's good to preserve those. Then we'll initialize register 2 to 0. And then we're going to load into register 3 the first byte from register 1. And that's 54. So let's actually see, look at the ASCII table and figure out what is 54. Hopefully it's the letter H. It's not. It's 6. Wait, that's hex. So hex 54 is the letter T. Why was I thinking it was H? What? Yeah, it would be T, because I think our message is like type your message or something like that. Okay, so that looks good. So T, and then the next one's probably going to be Y. But let's go let's step forward, and now register 2 will be increased by 1, and it was. Now we go back to the beginning of the loop. Now we get our next character, which is 79, and 79 in hex is what? Should be Y, I'm guessing. can't see it. Yeah, it's the letter Y. Okay, so it's correctly loading the characters. So now let's just quickly step through and see what the count is when it's done, just to make sure the count is working. And we expect to have a count of F in register 2, because that's 15. So we got 8, 9, now A, B, C, D, E. So we're getting very close. And then now we're up to F. Now we should be loading in the line feed, which is so R3 now contains the value, hex value 59, which is what? That doesn't seem right to me. Oh wait, no, we have a colon in there, right? Maybe I counted wrong. Hang on. 59 is what? It is 59 is capital letter Y. What is that? That's weird. Oh. I know what's wrong. All right, let me continue through to the end. Let's quit. I know exactly what's wrong. Continue through to the end. Quit. No. Okay, continue. Continue. Okay, quit. Yes. I know exactly what's wrong. Or at least one of the problems. In main.s, I never changed these to ASCIIs with the Z. So it's not finding the null byte. So I need to change all these to Z. Because remember, that was one of the requirements going forward. Now we could have left these as I, and then we could manually add the null byte, or if we were going to leave these as I, then we would have to update our print function so that the first thing it would do would be to add a null byte to the end of the string, but it's easier just to do this because it does it for you. Okay, so let's write that. Let's quit. Clear the screen. Let's remake our code. And now actually let's just run it. All right, so there's still an issue here, obviously. Let me think. We load into register 1 our prompt, and then we branch and link to print, and that is kind of goofing everything up. So let's look at print. So I'm looking at the loop. We load the first byte in, we do all that. I should probably go through the debugger again just to make sure it's counting correctly. Pop off. Branch if equal down to finished. Seems right. Let me... Yeah, let me run this through the debugger again. So let's make clear GDB main, and let's just set a breakpoint right at the top so we don't have to think about where to put it. And then I'll run the code, and we'll step into print again. And I just want to kind of go through print quickly, just to make sure that by the time we get to the end, R2 contains the value 15. So C, D, E, F. Now we go back to the top of the loop. We load the next byte, which I expect to be R3. Yeah, so it contains 0. That's correct. Now when we do the compare, that should set the flag. And now branch equal to finish should go to finished. It does. And now standard out. Yep. So register 0 should be loaded with the value 1. It wasn't. Or yeah, no it was. Register 0 was loaded with 1. Register 7 should be loaded with 4. Is it 4? Writing is 4, yeah, so that's right. And then we do the supervisor call, which should print our prompt. So step, and let's see what it printed. It printed you win. Okay, so quit, yes. Am I loading the wrong thing here? No, I'm loading the prompt. I'm loading the prompt into register 1. Then we're doing branch and exchange to the print function. Well, I tell you one thing. Actually, now all these, I was trying to test just one of these, but honestly now all these need to be changed as well because we've changed from ASCII to ASCII, so that could be messing all these up. So let me change, oh wait, what am I doing? I don't want to change those. I want to change anytime we're doing a write. So let me search for write. So this one, and then this should be branch and exchange to print. And the same thing here, because this is a write. Branch and exchange to print. And then lastly, and then finally, branch and exchange to print. Write that. Okay, so quit, make, clear, main. So it's still, yeah, it's still goofed up. 88. What am I not doing right here? So it's counting the characters correctly. At least it counted prompt correctly. The weird thing is it's printing you win, not, it's not printing type a number. It's counting type a number correctly. All right, there has to be an issue in here. So R1 must be preloaded with the string to be printed before this function is called. The string that is loaded into R1 must be of type ASCII, not ASCII. This ensures the string will have a null byte at the end. Okay, so we're good there. We come into print, we push everything onto the stack. We initialize register 2 to 0. We enter into the loop. We load. Oh, actually, you know what? I think I have to reset the pointer to our message, because as you go through here, as you do the load register byte, I think it. Yeah. Let me think about this. So here's what I'm thinking I might have to do. Make a copy of R1 by copying it into R4. And then when we get to this point, copy R4 back into R1. So there's actually probably a better way to do that. But I think what's happening is like a pointer issue, essentially. Which would mean if this is correct, then we also need to save that register. So actually we can simplify this a little bit. We can just say save registers R0 through R4 and R7. Actually, come to think of it, let me try one thing first, because I noticed something else. I don't know if this matters, but I'm not pushing R1 onto the stack. I'm not sure if that would be it. It doesn't seem to me like it would be. Okay, no. Alright, I just wanted to check that really quick. So let's do this. Let's push R1 through R3, actually R4, onto the stack, plus R7 and link register. And then we'll copy that down here. And we'll pop those off. And then what I think I might need to do is to save a copy of R1 into R4, and then right before we make our service call, we need to restore R1 from R4. And again, I think there's probably a better way to do that if that is the issue. Or am I just insane? Seems to have fixed it. Okay. Yeah, so what seems to be happening is when we initially load in main, when we load the prompt into R1, we have what I'm imagining is like a pointer to the to the first character of that message. And then as we're going through and we're doing LDRB, we're moving that pointer through the message. So by the time we get down here to print it, we're now 15 characters past the beginning of the message. So that's what's messing everything up. So this works by making a copy of register 1 and then restoring it. But I feel like there's another way to do that. I guess I won't worry about it for now because it seems to be working well. So for now, let's go ahead and fix up our main function. That is something I want to look into though. But at least we have this working. So let's get rid of all these extra lines that we don't need anymore now that we got this working. That way it will, clean up this. That's not what I meant to do. There. So that, turns printing a line to the screen from, 5 lines down to 2. So it's still not great. Like, it's still not perfect. It's still not as nice as, like, print hello world like you would have in Python, or like puts hello world like you would have in C, or printf, also a C thing. But it's better than what we had before, for sure. All right, so let's write that out. Let's recompile or reassemble everything again since we got rid of all those extra lines, and let's just do another quick check. So, 10, 100, 20, 1,000, A, B, C. I think I'd kind of like to handle those characters as well, but we can do that later. All right, awesome. So that's working. So I think, what is this, video 6? So let's make dir vid6 and copy main s into vid6, copy print into vid6, and copy our makefile into vid6. That way we've got a backup of everything. All right, well, thank you so much for watching. Hope you're enjoying going through this with me. I'm definitely remembering a lot of things and learning new things as I'm going here, so this is quite entertaining to me, at least. With all that said, I'll see you in the next video.